All right, let's go ahead and get started. It's nice to see a lot of familiar faces back from last semester, as well as new people who are joining. I'm Professor Doug Schmidt, and I'll be teaching the CS 282 class this semester. The topic of the course you'll soon learn about. It's nominally called something like CS 282 Advanced Operating System Principles 2 or something like that. But that's really just a code word, and I'll explain later what it actually is going to be covering. In fact, we'll spend a lot of time today going over what we're going to be covering in the course. There's a lot of interesting things we're going to do today. I was an advisor for the freshmen last night. I went over to the dorms in the residential college and met with a hall full of VOSE undergrads who are going to start today with their freshman experience for real. And they asked me a bunch of questions. And one of the questions was, do we actually do anything in class the first day? And so I tried to assure them that really varied quite dramatically based on who the professor was. But I can assure you we will do a lot of interesting things in class today. A couple questions. First, how many people took CS 251 so far? OK, so quite a large number of people. How many people took CS 251 from me? OK, great. So for those of you who didn't take CS 251 with me, I'll give you a pointer shortly to where you can go if you need to refresh yourself on some of the topics that we covered there. You'll see why that's important in the topics we're going to cover here today. OK, so what we're going to do to start out with is kind of talk about the class, what we're going to be covering. For those of you who are still perhaps undecided as to whether you want to take the class or not, this will give you a chance to see the big picture view of what we're going to be covering. Can you guess from the picture on the slide what one of the topics might be? Android, that's right. This is an Android. So that's a giveaway. Now, I mentioned before that you could go and find other information about this stuff. So this is the link that you'll get if you click on what I showed. And this is basically videos from CS 251. Those of you who took CS 251 probably don't need to go back and watch those again, although they're all there. Those of you who didn't take CS 251, there is some stuff we're going to cover here related to design patterns, and it might not hurt to go back and watch some of those things. There's also a playlist from the last time I taught this class, which was a year ago. You can watch some of that if you're really curious, but we're doing a lot of new and different material. There also is material here from other things that are related to the topic of the course, so I'll cover that as the need arises. All right, let's go back over here. And there we go. OK, now it's still working. So let's start off kind of talking about the course introduction, which is really sort of the overture to everything we're going to cover, give you an overview of the whole thing. Then I'm going to talk about some of the foundational issues that we're going to cover in the course. These are going to be things like what is Android, and some of the background on patterns and frameworks, some of which you know, some of which you may not know. We'll spend the bulk of the course on topics related to Android concurrency, which is going to involve, as you'll see, Java concurrency, and then a bunch of Android concurrency, and I'll compare and contrast how those relate to each other. Once we cover that material, you'll then be in a good position to understand some of the other topics related to Android, things like services, content providers, and remote and local inter-process communication. Very, very cool, very important stuff. And then something we'll do probably towards the end of the class, although we'll touch upon it along the way, is we'll take a more explicit look at patterns and frameworks related to all the Android programming that we do, concurrent Android programming, communication, services, other content-related stuff for structured data management, and so on. So those are sort of the big picture items of what we're going to cover in this semester. So let's first sort of talk about the course introduction. That's what we're about to do now. If you took 251 last semester, you know I love analogies to Lord of the Rings. So you'll see lots of them. In fact, there'll be an assignment in the course, which we'll talk about later, that relates to Palantiri, if you know what that is. And so basically, there's a great quote from Bilbo Baggins where he says essentially, just stepping out your door will lead you to all kinds of interesting adventures. And that's kind of what we're going to do here. We're starting an interesting adventure in the topics related to Android and concurrency. So one of the very first things we're going to talk about starting on Monday is we're going to start covering what is Android. And we're going to take a look at this from a couple of points of view. Android is a layered set of hardware and software capabilities and services and features and libraries and frameworks and all kinds of good stuff. And so we'll spend most of the time on Monday going over the layers of Android, particularly as it pertains to concurrent and communication-oriented operations. We'll talk a bit about the broader issues as well, but it's really about concurrency and communication. Those are the key themes. And we're also going to spend some time, probably on Monday, if we get through the layering part, talking about the key Android components. And you'll see later, because you'll be exposed to this over and over again, there are 4 major components in the Android architecture, things called activities, services, content providers, and broadcast receivers. We're going to spend the bulk of our time on services, with a little bit of time on content providers and probably even a little bit less time on broadcast receivers, which are sort of deprecated is too strong a word, but there are issues with the security aspects of broadcast receivers you have to be careful of. We'll also give you a chance to do some stuff with activities, but I'm not going to teach a lot of it in class. I'll give you some pointers where you can learn about that. The other thing we're going to start talking about, and we'll probably get to this probably next Wednesday, is we're going to start going over an overview of concurrency. And we're going to talk about some of the key reasons for using concurrency in the first place. Why would you want to make things be concurrent? Why would you want to have them run at the same time? Concurrency basically involves allowing operations to run either logically or physically at the same time, multiple things being run. Nowadays, they typically run on multiple cores, so they actually do physically run at the same time. If you only have a single processor or a single core, it might logically run at the same time. And we'll talk about that. And we'll talk about a number of the accidental and inherent complexities in that space. We'll talk about things like synchronization, and we'll talk about the different dimensions of synchronization, things having to do with mutual exclusion and coordination as 2 of the aspects of synchronization. We'll also talk about some of the gotchas you have to be careful of, things like deadlock. We'll talk about performance issues, how do you tune your system, how do you measure performance, how do you debug concurrent programs, and so on and so forth. And a lot of this discussion will give you both the motivation for why you would do this, as well as some of the common traps and pitfalls you have to be aware of. And so we'll talk about both the pros and cons of concurrency. We'll be using an example throughout a big chunk of the course that relates to something that's called the threaded downloads application. As you'll see, this will probably, of course, put up pictures of leaves. I figured that's what it would do. Let me get out of the... that's so funny. Let's exit the show. At least it's a nice, pleasant, happy picture when it's doing this. Let's go over here. So you'll see that all the source code that we're going to have here for our purposes will be in a so-called GitHub repository, and you'll be learning more about this in a second. There'll be some assignments. We'll talk about those. There'll also be some examples. And all of this stuff will either run with Eclipse with Android or Eclipse with Java, and you'll get a chance to learn how all that stuff works. So this threaded downloads application, which we're going to kind of walk through and use as a case study to show off a bunch of cool concurrency models and concurrency frameworks in Android, that'll be one of the things we'll look at. So if you're curious, you might want to take a look. It's a really cool set of things. And basically, it allows you to be able to concurrently download images and display them on your device. We'll then start talking about patterns and frameworks. My guess is, it depends on how much we get through on Monday. We might start some of this stuff on Wednesday. My guess is we'll probably start it a week from Monday. And this will really be giving you some more background on things, some of which you already know, since we've covered patterns. So I'm not going to spend a lot of time on patterns in a very abstract or overview sense. But we're going to start zooming in on patterns related to concurrency and communication, which is stuff we didn't really cover in any detail at all in CS251. So as you probably all remember, a pattern is a solution to a recurring problem that occurs in a particular context. And if you took 251 with me, you know patterns like bridge and proxy and adapter and iterator and all that kind of good stuff that we talked about with STL strategy and so on. You may recall that patterns, the purpose of patterns is to help codify design expertise, so that people don't have to go out and reinvent it all or relearn it all through the school of hard knocks. So it's very helpful. Frameworks, which we really didn't talk much at all about in CS251, are kind of the embodiment of patterns in software form. So patterns are abstractions. They appear in UML diagrams. They appear on whiteboards or on cocktail napkins or in your head or something like that. Frameworks are actually real artifacts. They're tangible. You can compile them, you can edit them, and so on. And so we're going to see that the combination of patterns and frameworks are very, very powerful. Frameworks are essentially a set of integrated components that collaborate to provide a reusable architecture for a family of related applications. And you don't have to worry about writing all that down if you don't want to. It'll all be in the slides and the videos. And so I'm just giving you the definition. That's basically about reifying, which is just a fancy word that means creating something concrete from something abstract. It's reifying the abstractions of design that patterns embody in real software. And you're going to get lots and lots and lots of exposure to frameworks. So basically, this class really, I think, does a nice job of complementing the things we covered in 251 and then taking it to the next level. Also, we're going to do everything here in Java. OK, so that's basically going to be section 1. So that'll probably take maybe a week and a half to cover. Section 2 is where we start really getting into my favorite part of the course, which is all about concurrency. And as you're going to see here, we're first going to start off by talking about some of the core Java concurrency mechanisms. Now, if you've done much Java programming, and by the way, we'll see later, you've got to know Java. If you're in this course and you don't know Java at all, it's going to be very painful. But hopefully everybody here who's taken CS sort of 101 has been exposed to Java. Even if you're not an expert at Java, most of this stuff is pretty easy to pick up if you know C++. So you'll see that in Java, they provide some built-in support for things called threads, which are basically units of execution that run in the context of some kind of process. And they run sequences of instructions, and you can have multiple of them running concurrently, all of which gets mapped down to the virtual machine and the operating system and the hardware and so on and so forth. So we're going to talk a bit about Java threads, and you get a chance to program some stuff with threads. And then we'll also talk about the basic Java concurrency mechanisms, concurrency control mechanisms, which in this case will be the monitor object, which is the core built-in mechanism for controlling access to things. And as we'll see, Java monitor objects support both mutual exclusion, keeping people out of so-called critical sections when multiple threads descend on those critical sections, as well as coordination or cooperation, helping things schedule their interactions and when they run. So that's going to be what we're going to cover first. Now, later in the course, if we have time, and I think we probably will, we'll cover a bunch more Java concurrency mechanisms. We'll cover reentrant locks, reentrant read-write locks, semaphores, condition objects, countdown latches, cyclic barriers, and then probably some other stuff like blocking array lists, or bounded blocking queues and list queues and all this kind of stuff. And these are basically mechanisms that are part of the Java class libraries that build on primitives typically implemented in hardware using special Java wrappers around hardware mechanisms that give you a very powerful suite of low-level locking primitives and synchronization primitives. We're not going to cover those things at first because you don't really need to know them for the bulk of what we cover with Android. Some things doesn't hurt to know them, but it's really, Android has a whole pile of stuff we'll talk about in a second that shields you from the knowledge or the need to use a lot of these low-level mechanisms. But it's important to have at least working knowledge of some of that stuff. So we'll probably come back later and talk about that. The main thing we're going to focus on in this section, section 2, will be the Android concurrency frameworks. And as you'll see, there are two predominant frameworks in Android, one of which is called handlers and messages and runnables, which I call the hammer framework. Handlers, messages, runnables, hammer. And that is a very interesting framework, which basically is a pattern called the command processor pattern, which we didn't really talk about in 251. And it's about creating commands, and then which are essentially runnables. They're instantiations or implementations of the runnable interface in Java, and then handing those things off to a command processor where they get run typically in a separate thread of control. So that's the hammer framework, and you'll get a lot of chance to play around with that. We'll also talk about async task, which is another framework, which is actually an implementation of something called the half-sync, half-async pattern, plus a few other patterns like template method that you learned about in 251, if you took the class with me. And we'll cover that framework. It's a little bit more object-oriented in a lot of ways. It appears at first glance a little harder to use or harder to program, but it's really, really cool. And we'll cover initially how to use it, And then much, much later in the course, we'll actually go and look at its implementation. In fact, we'll look at the implementation of lots of this stuff. So you'll get a chance to learn not just how to use it, but also eventually how it works under the hood, which is pretty cool too. As you'll see, when we talk about these frameworks, there's a lot of object-oriented design built into them. So a lot of the stuff that you learned about in 251 about object-oriented design and patterns and decomposition and composition, all that stuff still applies, and you'll get a chance to see that. Unlike the C++ standard template library, which we focused on heavily in 251, most of the stuff in Java uses classic object-oriented features like inheritance and dynamic binding through virtual functions. There's a little bit of generics here or there, but it's not nearly as pervasive as you find it in C++, where template metaprogramming and generic programming is the paradigm that's become widely adopted. So that's kind of an interesting shift to go back and forth and think in different ways. I like both approaches. They have different purposes and different pros and cons. We'll also talk, of course, about patterns that relate to concurrency, synchronization, communication, and so on. So we'll cover this stuff from a broad spectrum of views, so you'll understand many different ways of looking at things. Not surprisingly, some of the patterns we'll talk about will come from the good old Gang of Four book that we covered in 251. So you'll see template method applied, you'll see strategy applied, you'll see iterator applied, you'll see a lot of your old favorite patterns. But there's going to be lots and lots more new patterns that we didn't get anywhere near having a chance to cover in 251 that we're going to cover here, because these are patterns that relate to concurrency, event handling, synchronization, communication, and so on. And they come from other books and literature on the topic of patterns. OK, so that'll be basically section 2, and that'll probably take several weeks to go through all that. There's a lot of material there. By the time we get done with that, you will have gotten a chance to build a couple of interesting concurrent applications, both using kind of classic Java level concurrency mechanisms like threads and monitor objects. We'll talk more about that in a minute. And you'll also have gotten a chance to build a couple of Android applications. In fact, you're going to get a chance to build an Android application very quickly here. Very simple one. Once we're done with that, then we're going to start taking a look at more advanced topics. Topics you still need in order to be able to be successful building mobile applications and mobile services, but things that are above and beyond the concurrency stuff we will have covered to this point. And this will basically involve 3 things: services, which we'll talk about in a second, content providers, and inter-process communication. So the first thing that you need to do to write even the most basic Android application is you have to understand something called an activity, which is basically an abstraction that provides a user-facing operation, like it prompts you to enter a URL, or it displays the output of something from an image or a file or whatever. And you'll get a chance to play around with one of those things real soon, like tonight. So those are activities. I'm only going to cover activities very, very briefly, probably when I go over the first programming assignment. And the reason for that is we're not really focusing on activities or user-facing programming in this course. In fact, we'll probably provide you with a lot of that stuff as part of the course, so you won't necessarily have to do a lot of that. If you want to learn more about activities, however, you can go take a look here at this website. You'll have to register for it. I'll talk about that in a second. There's a couple of really nice lectures by a colleague of mine named Professor Adam Porter at University of Maryland talking about activities. And it's probably 20 minutes worth of video. It'll give you everything you need to know about activities, certainly in order to do the first programming assignment. You could probably do the first programming assignment without even watching those videos, but that'll give you a nice overview. So feel free to take a look at that, and that'll get you started. Where we're going to spend more of our time, however, is on services. So if activities are about user-facing operations, services are about things that kind of run in the background. And I'll use that term loosely for now, because we'll come back and cover what that means in more detail. But basically, they're things that are used. They are not user-facing. They cannot communicate to the user directly. And they're typically used to run operations that have to run for a long time, or you want to make reusable for adoption by other applications. So it's about reuse, it's about packaging things up, it's about stuff that can run in the background. They're also very useful for long-running operations that we don't want to distract the user interface thread, and you'll see why that distinction is important later. For example, when we do our image download application, the threaded downloads application, you'll see how we use a service in order to be able to shield the application from the details of how we do the communication with the server how we download the image, where we store the image, and so on. And all the user is going to get back, the activity is going to get back, is just a path name to a file that can be used to display the image. And all the details are pushed kind of into the background, as it were. There are a couple of different kinds of services in Android, and we're going to cover them both in great detail. You'll get a chance to program them. The first kind of service is called a started service, and these are services that are typically usually used for sort of one-shot kinds of things. You want to start up something to run kind of in the background to do a job, and when it's done, it typically shuts itself down. So it's launched on demand. We'll talk about the patterns and other design techniques used for that later. It's basically the activator pattern that's used to launch these things. And then we'll also talk about something called bound services. And bound services are services that live as long as there's a client that's accessing them. So they might live for a very long period of time, in fact. And they're often used to be able to have longer running conversations. So a started service is typically used for an activity to kick something off, and it goes and runs and does its job, and then it goes away. A bound service is typically used for something that's going to communicate back and forth, interacting for some period of time, having a conversation between an activity and a service. And we'll talk a lot more about those things. So activities are the user-facing things. Services are things that run in the background. How do they talk to each other? Well, on Android, they support something called inter-process communication. And that allows the services to run in one process and the activity to run in another, or activities to run in others. And then they can talk back and forth by doing things. One way they can talk back and forth is to have the services pass information, or sorry, the activities pass information to the services via something called an intent. Intents are very important in Android. They're basically data structures that hold information used to start stuff and to communicate things to stuff that's started. We'll learn more about intents as we go along. So that's one way to talk. There's also a way to use something called a messenger, which is basically a way to pass a message containing various fields and other metadata from one address space to another, or from one service or activity to another. So messengers are often used to talk back from a service back to the activity that invoked it. And we'll talk a lot about that. You'll probably get a chance to program some stuff with messengers and intents. There's other ways to communicate on Android as well. There's also this concept of basically remote procedure call or remote method call. And this uses something called the binder. And actually, intents and messengers use the binder as well. The binder framework is a set of classes largely implemented in C and C++ that reside largely in the Linux kernel and are used to do high-performance communication between address spaces on Android. So binders are used to send information back and forth across processes, and we will spend a lot of time talking about this. This is basically the broker and proxy patterns. And you access the information exposed or managed through binders through something called the Android Interface Definition Language, AIDL, which basically looks a bit like Java interfaces, and you use it to describe the shape of what you're trying to do in terms of the methods, signatures, the parameters, and so on. And then code is generated for you automatically that handles some of the low-level marshalling and demarshalling and encoding and decoding and linearization and delinearization and so on, needed to move things from Java applications running in one address space to Java applications running in another, or Java applications in one address space and C or C++ applications running in another address space. Lawrence?
So it's kind of like using pre-written Java native methods?
Is it like using Java native methods? Java native methods solve a slightly different purpose, which is largely to be able to go from the Java world into the C or C++ world. But that's usually just sort of from one domain to another, from the Java world into the C world. The binder framework allows you to go across address spaces, whereas the Java native interface just lets you go between the Java world and a C or C++ world. So it's not quite the same thing, but they're both transforming stuff, let's put it that way. There's more work required to go from the one address space to another in terms of doing special things to the parameter values to get them in the right format to go across address spaces than there is to go from Java to C or C++. That transformation is much simpler. But we'll learn all about that stuff. The next thing we're going to do in this particular section is talk about network programming. So everything I just talked to you was how you talk between address spaces on the same device, on your tablet, on your smartphone. But we're also going to spend time talking about things that go from your device to the cloud or to a server somewhere. And we're not going to spend much time in this class on the server side, although we'll talk about that later. We're going to spend our time on the cloud server side. We're going to spend our time more on the phone server side. So services are basically servers running on the phone, and you'll get a chance to play around with that. And we'll talk about sockets. We'll talk about some of the HTTP clients that are provided by Apache or Android.net. And there's some really, really cool things. You'll get a chance to play around with JSON as well, which is an encoding format to move things back and forth in the web. So that's how we're going to go from your device to some remote server or web service somewhere. But once you get the data back to the device, you typically want to store it somewhere persistently so you can access it over time. And to do that effectively, we're going to talk about things called content providers and content resolvers, which are basically proxies that allow you to access content providers. Content providers are really abstractions that provide the so-called CRUD operations, create, read, update, delete, which are things you use for databases. And they're usually front ends to SQLite. Not always, but usually front ends to SQLite. So we'll talk about SQLite, and you'll get a chance to play around with this. This will also give us a chance, when we get to this part of the course, to talk about different concurrency models for accessing content providers, either with threads or various kinds of asynchronous programming. And it's really cool. I've got a really neat example I've got cooked up that you get a chance to play around with that'll expose you to all kinds of interesting things in that space. OK, so that's basically section, whoops, this is supposed to be section 4. Hold on a second. That's an off by 1 error. OK, so that was section 3. So here's section 4. Section 4, and we're going to have to see how much time we have by the time we get through everything else with this. This is where we're going to actually go through and systematically look at the patterns as patterns. Right? Before, we will have been looking at features in Android, frameworks, and various Java concurrency mechanisms. And we'll mention patterns in passing along the way. But here's where we're actually going to look at patterns as first-class topics in the course. And the other really cool thing about this is if we have the time, we'll get a chance to walk through the Android source code. So you'll get to see how it's implemented under the hood, which is absolutely fascinating. And at least I find it absolutely fascinating. So I have taught this course in the past, and I had to spend a lot of time really understanding how the frameworks work in Java and in Android. And there's some great, great, great stuff lurking there. And it's very, very pattern-oriented. And a lot of the stuff was written by a friend and colleague of mine named Doug Lee, who's written many, many, many Java concurrency libraries over the time. And he's just a master at writing object-oriented, pattern-oriented framework code. So I get a lot out of just looking at his code. It's very enlightening. So you get a chance to look at a lot of code. Here are some of the patterns we're going to cover. I'm not going to go through them in detail, but there's about a half dozen patterns related to concurrency. There's about a half dozen patterns related to communication. And if we all goes well, we'll have a chance to cover all of those. And you'll not only understand the patterns, but you'll also understand how they appear in Android. And what's particularly cool about this is that these patterns were not developed with Android in mind. They were developed or it's discovered in a very different context than Android. And yet the people who were developing Android adopted many of these patterns, either intentionally or unintentionally, in the way that they built their frameworks. So it's a great, great way to learn about stuff. By the way, I had a fun experience. I got an email just a couple weeks ago from a student who took CS251 last semester. And he was like raving about how great it was, because he went and did a summer internship this summer. And he's like, wow, all the stuff we did in 251, we covered source code control. Well, I had to know that on my internship. We covered patterns. I had to know that on my internship. And everybody was really impressed because I knew all this stuff, right? So this class is going to give you the same experience, just kind of up a notch. The patterns we're going to cover here, we will cover in the context of Java and Android and mobile programming, but they're much more fundamental. So if you do server-side stuff in Java, you do server-side stuff in C++ or C or Python, pretty much pick any technology that's concurrent communication related, you will find these patterns lurking there somewhere or another. OK, so to summarize this particular intro section, there are 4 main things we're going to cover in this course. Java concurrency, Android concurrency. That's my icon for Android concurrency, because he's got a hammer, right? It's like the hammer framework. Patterns for concurrency, and frameworks that are for concurrency and communication. So those are the 4 main things. So in case there was any doubt about what we're going to cover, that's what we're going to cover. When I taught the class last semester or last time, someone got to the very end and they wrote, we thought this class was about operating systems. So they'd taken 14 weeks of this stuff expecting operating systems to show up at some point. Of course, the ironic part is this is an operating system. This is a modern operating system. This is not an operating system course on device drivers and kernel programming and interrupt handlers, which is an interesting topic, but honestly, just about nobody works at that level anymore. This is a course on the new generation of operating system. Advanced operating systems, that's the title after all, right? Which is basically middleware. And if you pay attention and you kind of squint, you'll realize that almost every topic we cover here related to patterns and frameworks and so on has a corollary relationship inside the real operating system kernel. It's just a lot grubbier to have to work in that space because it's in C and it's low level and it's full of accidental complexity and so on. But the concepts and topics are very similar. What you should be able to come out of this course with is an awareness of what inherent and accidental complexities are in the space of concurrency and communication. You will know how to apply patterns and frameworks to build applications that are concurrent and run on mobile devices. You'll know where to find more information because we'll have lots and lots of pointers to stuff. And you'll also have a chance to analyze a lot of Android source code. So I highly recommend getting the Android source code. You can either get it, and if you want to search it, you can go to this link, and I'll give this, there's other links too. You can either search it there, or you can actually download it and use it on your machine. And it's absolutely essential to understand how to use Java. If for some strange reason you do not know Java, or you want a refresher on Java, then if you go to the FAQ for this course, we'll look more at this in a second, and look at item number 4 in the FAQ, it gives you a pointer to a free class by, I think it's Udacity, on Java. So if you really don't know Java, but you still want to take the course, that might be a place to go. If you don't know Java, though, it's going to be hard to take the course. OK, so that was a quick overview. Any questions about that? So now you sort of know what you're signing up for.